So let's wrap this chapter up by actually taking a look at some applications. So this first application, we're talking about a temperature in a fictional place called Bumsville, Arizona, right? And we find that in this area, the temperature can be modeled by the function t of x equals 78.8 minus 17.3 times the cosine of 2 pi over 36x. All right, and so it's basically a cosine graph that's being manipulated. So T is the temperature in degrees, and X is the day in the years. So what they want us to do is answer the following. What is the equilibrium temperature? Right? Well, the equilibrium temperature, right, that's basically in our, how about we do this again, f of x equals some A cosine B x minus D plus C. So C is usually our equilibrium temperature. So when I look at this, it's kind of written in reverse, but if you want, right, this 78.8, I can write it like that so it actually kind of fits the function that we have. So basically cosine, doesn't really matter what's inside of here, is bouncing between -1 and 1. The 17/3 is making the amplitude go that way, and we keep bouncing 17.3 from 78.8. So there's our equilibrium temperature right there. So 78.8 degrees is this equilibrium temperature. So it probably tells you that Bumsville is probably up north somewhere by Flagstaff, right? Because I don't know if Phoenix has a nice temperature like that on average. What's the maximum and minimum temperature? Well, the amplitude is 17.3. So basically the way the amplitude works is to get a max, we're by the equilibrium plus that. So your max is 78.8 plus 17.3. So I think when we do the math there, 8 and 3 is 11, carry the 1. We get 16, carry the 1, 7, looks like 96. So I'm getting 96.1 degrees, if I did my math right there, is the max. To get the min, we take our average temperature and we subtract, right, the amplitude, because the amplitude's above it and below it. And so when we do the math here, 8 take away 3 is 5, 8 take away 7 is 1, 7 take away 1 is 61. So 61.5. So its minimum temperature is about 61.5, and its high temperature is about 96.1. All right, and again, this is just on average. What about the period? Well, we know the period is 2 pi over whatever B is. And so looking at this, our B is 2 pi over 365. So we're going to take 2 pi, divide it by 2 pi over 365. Of course, if we divide by a fraction, that means we are actually multiplying by reciprocal, and we get what we typically think of, right? There's 365 days in a year. So one whole 365-day period is basically going to match one complete cycle, one complete year. Is there a phase shift? Well, when we take a look in here, we're not subtracting or adding anything to x, so d is equal to 0. So there is no phase shift. All right, so nice and neat. The function was given to us. All we had to do was tie in what we've learned about A, B, C, and D and give them meaning, right? Because in this case, it was temperature meaning, day meaning, and all that other good stuff. So how about we stop there? Number 9, we have no equation, but we are told we're going to be trying to fit a cosine equation, but we have no graph. So what do we do? All right, so I'll show you that in the next video.